Hi there, and welcome back to the module on on-site technologies for collection, storage, and partial treatment for the emergency context. After learning the theory behind sanitation in humanitarian responses, it is now time to have a look at some of the technologies that can be used. In this module, you will learn about different on-site technologies that are suited for an acute humanitarian crisis. Remember that there are many criteria that will determine whether the technology is suitable for a context. We will have a look at one technology that can be categorized as a user interface, the shallow trench latrine, a simple upgrade to controlled open defecation. Then you will be introduced to 5 on-site technologies from the collection and storage/treatment functional group. Please note that this list is in no way complete and that you should consult other literature in order to find the best technology for your context. During an acute humanitarian crisis, it might be that sanitation infrastructure is completely destroyed or unusable in the short to medium term. People will still need to defecate, and until another sanitation system exists, they are often forced to defecate in the open. This is a major health threat as it can spread diseases such as diarrhea, cholera, or typhus. Therefore, usually the first measure until materials for improved latrine construction are available is to control the open defecation that is going on. This means that designated areas should be allocated where open defecation is allowed. For example, a field away from health centers, schools, or food places such as kitchens and markets. There are several easy measures to improve a controlled open defecation field. Digging shallow trenches will make decommissioning of such a field easier, providing minimal privacy with simple screens can make it more dignified to use, and hand washing facilities will further enhance hygienic conditions. The way it works is simple. Shallow trenches are dug. People defecate into the trenches. There needs to be a manager of the field that can provide safety and decommissions a trench when it is full by covering it with the dug soil. After the use of this technology, the soil needs to be secured from the community and finally treated. This method can be a suitable option in the immediate aftermath of a crisis, due to the low complexity and low capital costs involved. It can be constructed with very simple tools and materials in a short period of time in less than a day. However, this solution should be quit after a couple of days, as it is not considered an improved and safe sanitation technology and does not provide the security and accessibility of an improved toilet as required by Sphere Standard No. 2 on excreta management. The risk of cross-contamination still exists, as flies and other vectors cannot be kept out. The land used needs to be rehabilitated afterwards, which can be very costly. About 0.25 square meters of land is needed per user per day. This is about half a football field for 10,000 inhabitants per day, and this will add up very quickly over the course of time and is therefore not a long-term solution. Slightly improved solutions are deep trench latrines. For this technology, a deep trench of approximately 1.5 to 3 meters is dug, and several dry toilet user interfaces consisting of a simple slab are built upon. The pit needs lining in order to prevent it from collapsing. This image shows how a deep trench latrine can be lined with corrugated plastic sheets and wood pillars. This can also be done with local materials such as corrugated sheet iron. This technology has the advantage of quick implementation time with local materials and low skills and capacity requirements. However, like all pit technologies, it is not suited for areas with a high groundwater table or rocky, unstable or clay soils. There is no ventilation possible and therefore flies and odors remain a nuisance. Sludge in a public deep trench latrine will accumulate very fast, and feasible emptying and transport solutions are therefore needed. Bear in mind that a deep trench latrine is not considered an improved toilet facility and should only be implemented in the acute phase of a humanitarian response when no other solutions are possible. A new service option that is being tested by different organizations is container-based toilets. Users defecate and urinate into buckets with a lid and are then emptied on a regular basis. Container-based toilets can be prefabricated with plastic molding or constructed out of readily available materials, such as buckets with a simple user interface. The user interface can be a dry toilet or a urine diverting dry toilet that separates feces and urine and collects them in two different containers. The main implication of this technology is that a reliable emptying service needs to be in place, as these toilets fill up very quickly. This service can be provided by private companies and can provide job opportunities for the affected community. A big advantage is that the toilets are mobile and can be used in existing superstructures with no need for substructures. They can also be used within the household. The mobile toilet can then be accessed day and night. This is a major plus to reduce the risk of gender-based violence by providing the safety of the private space. Furthermore, it can be used to manage child feces, an issue that is often overlooked. They are also appropriate for flooded areas or where the groundwater table is very high. A major implication is that the system depends on a high quality and regular collection service, and further treatment is needed. Users need to be well trained and have to buy into this technology. This might require sustainable awareness raising, and there is a risk that users could reject to use this technology. Chemical toilets are another example of prefabricated, ready-to-deploy toilet facilities that can be delivered as a complete unit without need for further construction on site. This image shows the deployment of a chemical toilet on an escape route in the Ukraine. In this technology, the excreta is hygienized and stabilized in the toilet with the help of liquid chemicals such as formaldehyde and glutaraldehyde. There are also biological degradable solutions that don't have disinfecting properties but can help reduce odors and unpleasant smells. These type of toilets are usually public and not suitable for a private household.
We are installing mobile latrines. What we are trying to do is that avoid people going into the grass, going into the forest, and I guess that we will save lives.
In the short video from Ukraine you just saw, the toilets were installed because the forest along the road was a minefield and therefore people couldn't go there for defecation. The big advantage of chemical toilets is that they can be mobilized rapidly if there is a service provider in the region. So far this is rather uncommon outside of Europe, North America and parts of Latin America. But mobile toilet businesses of different kinds are emerging. The toilets are usually very well accepted and they are very appropriate where digging a pit is not possible. However, chemical toilets are not a long-term solution and need to be replaced with a complete sanitation system. They need daily servicing and therefore a service provider. This can become very costly or impossible if such a provider does not exist. Furthermore, a wastewater treatment plant is needed to treat this sludge, and laws and regulations need to be in favor of dumping the human waste from such toilets into wastewater treatment plants. A borehole latrine is a technology that is used mainly in the acute response phase, when a large number of latrines need to be constructed rapidly and the site conditions do not allow for excavation of bigger pits. With a borehole driller available, this can be a quick way of digging a great number of latrines within a very short period of time. A dry toilet can be used as a user face on top. The borehole is then used like any other pit. A lining of the pit in the top section is also required, especially when there is an unstable soil. For obvious reasons, this technology can only be implemented with a borehole driller available on site. If so, it is a very inexpensive and quick way to construct, easily understood, and only requires a small workforce. The requirements for the superstructure remain the same as with any other pit-based technology. As there is no ventilation possible, odors and flies are often a problem. The toilets are not suited for unstable soils and high groundwater tables. Also, the lifespan of a borehole latrine can be quite short and therefore a new system is needed soon after they are constructed. Lime treatment can be used for fecal sludge treatment. Lime is a fine white powder of which a sufficient amount is added to sludge and then mixed in a container. This increases the pH to 12. A high pH over enough time disinfects the sludge, and slows down or stops biological processes responsible for odors. As mixing is crucial to the process, the technology usually consists of a tank and a mixing device. On this image, an open tank is used and lime is added and mixed manually. Workers are wearing protective gear, as there is a potential health risk if not handled properly. The correct combination of dosage and retention time of lime is crucial for this treatment and depends on the total solids of the sludge and other chemical characteristics. Therefore, the local fecal sludge has to be tested in order to determine the correct dosage. Typically, it is around 20 to 35% of lime per dry mass of sludge. Lime costs around $100 to $800 per ton in different countries. Lime treatment is very useful due to the short treatment time of the sludge. The process is simple and uses materials that are usually locally available. But it has to be noted that pathogen regrowth will occur again once the pH drops below 11, and therefore lime treatment is rather a temporary stabilization than a long-term treatment solution. So, in this video we learned about different feasible technologies that can be used during an acute humanitarian crisis. Technologies that can be implemented quickly, that mostly use locally available materials, that can be replicated and upgraded, and that serve a large number of people are preferred. So thank you very much for your attention and hope to exchange with you on the forum about different technologies. Thank you very much.